All right, so for today's notes, we're going to continue working with our linear relationships and story problems. This one is called the Rule of Four. The reason it's called the Rule of Four is to work on making a connection between a verbal description, the equation, the table of values, and the graph. So let's go ahead, read through this, and then kind of complete this as we go. So we have the t-shirt shop. Your new job is at the custom t-shop where t-shirts are printed to order. For each order, custom t-shop charges $8 per shirt plus a one-time setup fee of $15. We're going to write and graph a linear equation to show how the total cost of the t-shirts depends on how many t-shirts are ordered. So the first thing we're going to do is define our variable. So this is nothing new. We've practiced this a lot so far. Remember that X is independent, Y is dependent. So your independent variable, I'm going to call this one our number of shirts. Okay, and depending on how many shirts we purchase, that will change our total cost. So Y is our total cost. Or you can think about it as our total cost depends on how many shirts are produced. Our equation, so if we go back here, it was $8 per shirt. Okay, here's that word per to kind of clue us in where slope is going to be, and then they tell us this one-time setup fee of $15. So we have 8x plus 15. So remember that this was written in the form of y equals mx plus b. M is your slope, and that's again why we underlined and circled the word per to clue us where slope would be. One-time setup fee, or our initial value, that's our B. Okay? All right, the next thing we're going to do is we're going to think of a table of values. And I want you to take a look at the graph that I've provided as well. So notice how this graph is just quadrant 1. And so when we think about our table of values and creating our graph, we really should not have any negative x values or really any negative y values for that case. Negative x is the number of shirts, so we would be starting at 0. So like factoring in your setup cost, okay, and then we would increase from there. So again, there's no reason to have negative x values. So we would have 1 shirt, 2 shirt, 3 shirts, 4 shirts, and 5 shirts. Okay. Now we've already had our test on writing the rule and how to do that. So what we can do right now is just use our calculator and substitute 0 in for x to find, and then add on 15 to find our y values. So 0 in for x plus 15 is 15. 1 in for x, that's going to be 8 plus 15 for 23. 2 in for x, so it's 2 times 8, which is 16. 16 plus 15 is 31. And then if we keep doing that, we get 24 plus 15, 32 plus 15, and our last one, 40 plus 15, is 55. Okay. Now the next thing that you're going to do, and we're going to be doing this on our homework as well, is notice that on your graph, nothing is labeled, and you need to be labeling. So we're going to label both of the axes and put in the numerical values. So what's nice is we know that we're going to start with 1 here, and you know, if I want to take a look at my x values, and here's my x-axis, my highest value is 5. So I can have this go up by increments of 1. So 1, 2, 3, 4, 5, 6, 7, 8. And then again, my x is my number of shirts, so we're going to go ahead and label our x values as so. Now my y, if I take a look at my y values, it starts at 15, it goes up to 55, and I have to think about, well, there's no way I have 55 on my y-axis, so I don't want to go up by 1. So then you have to think about other options. Go up by 2, by 3, 4, 5, and so on. So I'm going to check going up by 5 real quick. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So actually 5 is the best. Remember, our goal is to have it as spread out as possible, but without having going over, but we also don't want to make it so it's too small. So if I went up by 10s, 10, 20, 30, 40, 50, I'm wasting so much of this graph. So 10 is too much of a change in increments. So you just kind of have to, it's like a guess and check to figure out what works. So 5 did work, so I'm going to go ahead and label. And so label the side that this is my total cost. And so just go ahead and from your table plot your points. So I have 0, 15, 1, 23, 2, 31, 3, 39, 4, 47, 5, 55. So once you have all of your points plotted, get a straight edge, connect your dots. As best as possible. Okay. Once you're done, let's flip it over to page 2. So on page 2, okay, we're doing more of the same. We have another positive linear relationship. We have Hans needs to rent a moving truck. Company A charges a rate of $40 per day. Company B charges a $60 fee plus $40 a day. We're going to start by writing our algebraic equation for the total cost based on the number of days D. So for A, it was 40 D. Okay, so again, using the variables that they supply. For company B, it's going to be C equals, and there's really 2 ways to write it. You can write it as the order that they give it to us is 60 plus 40D, or you can write it in the slope-intercept form, 40D plus 60. Okay. Then we'll just go right in order. We're going to create that table again. And our first one, they give us from 0 to 5, so we put 0 in for D and solve for C, and that is 0. 1 in for D, that's 40. 2 in for D, so 2 times 40, we get 80. 3 in for D, so 3 times 40, and then 5 in for D. Okay, then we're going to do the same thing. So notice how the x coordinates, or in this case the d coordinates, are not supplied for us. So we're going to just mimic it. So it'll be 0, 1, 2, 3, 5. If neither one was given to us, we would have to use that same logic that we did on the front page where, you know, pick values that make sense for this story problem. Start at 1 and increase, or I'm sorry, start at 0 and increase from there. So if I put 0 in for D, I have 60. 1 in for D, so 40 plus 60. 2 in for D, so 80 plus 60. Or I can just look across here, 120 plus 60. 200 plus 60. And then we have our table. Now the next thing we're going to do is we are going to put this on our coordinate plane. And so I did give you the values on this one, but what I'm going to ask that you guys do is label, okay, when it's missing. So we'll go ahead and label this one as the number of days. And our y-axis is the cost, okay? And so it's given to us in dollars. And so let's go ahead, and you know what I'm going to do is I'm going to use 2 different colored pens for this one. It's our notes, and if you can, why don't you do the same? So I'm going to start with our company A, our first one, where I have 0, 0 is our starting point. and then it is 140. Notice the increment change in the Y values, so it works for this one because our highest value is 260, and I had them move by 20 to get 260 in there. So anyway, going on to 2, it was 2 and 80, 3 and 120, and 5, so don't go to 4, go to 5, is 200. Okay, and so when you draw this line, have this one extend past, and then we're going to label this line. We always want to make sure that we're labeling lines, especially with story problems, when there's more than one line on the graph. So this one was C equals 40D. Okay, and then company B, when X is 0, Y is 60, so we have a different starting value, and then same increment of increase of by 40. So that means, hopefully this makes sense, that they have the same slope. And these lines are parallel. So again, just do the same thing. And when you are done, label this line as well. So I'm going to label this. Like so. Right next to each one, so it's easy to find. Now the last thing that we're going to do is we are going to describe the X and the Y intercept. Okay, so for the X intercept, company B doesn't have an X-intercept, so we're going to go ahead and just write in that company B has none. But we can describe the Y-intercept. So this is before any days of moving, the starting cost of both moving truck companies. Okay, so before any days of moving, the starting cost of both moving truck companies. Okay. That's it for these notes. We only have one more problem like this that we'll do next time I see you in class. Over and out.